This is the non-calculator November 2014 paper. Before you start, obviously read the front page, but the main bit to highlight will be down here. Questions labelled with an asterisk are ones where the quality of your written communication will be assessed. So you're supposed to write in sentences, you're supposed to tell the examiner what you're doing, otherwise it's likely that you either won't get the marks or you won't get full marks. Right. Yes, excuse my writing, I'm at a slight angle, but there we go. By now, if you're scared of this page, you're in trouble. It is not a question, it's the formula sheet. Those of you who are hoping to get up to a C, concentrate on these formula at the top here, especially this one. Volume of a prism is the area of the end multiplied by the length. It can go for any prism, but in general, the type of question that will come up will be one where you've got an L shape, so you work out the area of the end and then you times it by the length. That's the sort of question that's likely to come up for that. For those, I'll try and fit that on the screen. For those that are working more from a C and above to a B or an A, this is where you're going to be looking, is down here, especially the quadratic equation. For the calculator paper, this is obviously a non-calculator paper, and down here for triangles, for right angle triangles you're going to be using Pythagoras and trigonometry, but for any other triangle you're likely to be using one of these formula down here. So as long as you've got that in your mind, that's fine. If you come across questions which are doing this and you don't know exactly what to do, just write down the formula and substitute things in. It may work, or you're likely to pick up 1 or 2 method marks. So there we go. Right. I shall leave that out. Question 1. Read the questions. Most people will look at this and they will start actually doing the multiplication. You don't need to do that. It says using the information, so they give you this for a reason. So you look at it and you think, well, hang on, some of these numbers are kind of similar. You've got a 6.7 there, 6.7 there, and you've got a 520 and a 52. So we use that information, and this is basically just moving your decimal point back and forward. So this here is the same as this. So what we've done here is we've increased it by a power of 10, so that's all we do for the answer. So your answer is going to be 3, 4, 8, 4, and that's it. For this one here, we've reduced it 2 to the left. In effect divided by 100, but we've also increased it by 1 there. So if we're going to have gone 2 to the left but 1 decimal to the right, we end up with a total of 1 to the left. So your answer will be 34.84. If you're not sure about this type of question, get your calculator and start playing around with it, but it's basically multiplying or dividing by powers of 10. This last one's a little bit harder, but again, same sort of deal. You look at here, it's basically a little bit of rearranging. So we'd rearrange the formula to be, we'd have a look at this and we go, right, 34.8.4 divided by 52 equals 6.7. Then we look what we've got. They have increased this and decrease that, but because it's on the bottom, if you decrease it, you're actually increasing it. So let's have a look. We've got, yeah, 670. Again, if you're uncertain, what you can do is kind of estimate and go 3,500 divided by 5. Well, that's going to be in the 600 odd range. Question 2. Karen got 32 out of 80 in a maths test. She got 38% in an English test. Karen wants to know if she got a higher percentage in maths or in English. So you're going to need to either convert this into a percentage or this into something out of 80. It's going to be easier to convert this into a percentage. So what you do with this is this whole scaling down, scaling up method. So we basically say 32 marks is out of 80. We want to get that to 100 because it's 100%. So you work out how you get down to 1 and then you go up to 100. So that's divide by 80 and times by 100. At this point you can kind of see that 8's actually going to 32. So what you could do is go down to 10, which means divided by 8, and then times by 10 to get back up to 100. So you do that on this side. And when you divide by 8, you get 4, and then when you times by your 10, you get 40. So this is 40%. So you can obviously see she got a higher mark in maths. Quite right too. So you obviously write your answer, make sure you actually answer the question, don't leave it there, actually write down what you've got. Okay, this one, stem and leaf, you should eat these up all day long. So you're going to look at your values here and think, right, I've got a column down here for tens, and then you're going to fill it in and you're going to remember to do a key over here. So I'm going to look at my lowest value, you're going to do it in order as well. My lowest value I think is 84, so I'm going to start with my 80s here. Then I've got my 90s, then my 100s, and my 110s. So just double check, get it in order. Done this paper before. 4. So the 8 and 4 makes 84. Then we've got 88, 89. No more 80s, so now we're on to our 90s, and we've got two 90s. I'm going to put the commas in. We've got a 91, 92. Oh no, two 91s. Be careful. That's why you cross them out as you go. 92, 93. Cross it out. 95. 97. And 98. Then we've got 102, 103, 106, 108, and finally we're into 110s and 115. So then you do a key, and you can pick any numbers. 2/4 equals 24. Just tell them about it. So that's 3 easy marks. Question 4. Kalinda buys X packs of currant buns and Y boxes of iced buns. Do not be scared by X and Y. Treat them like numbers for the minute. There are 6 currant buns in a pack of currant buns. There are 8 iced buns in a box of iced buns. That's a lot of buns. Kalinda buys a total of T buns. Write down a formula for T in terms of X and Y. So if you're struggling with this, put numbers in here and say, you know, if she bought 3 packs of currant buns, how many would she have? So that's 3 times 6. If she had 3 boxes of ice buns, again it's 3 times 8. So that's all you write down, but you just then replace it with letters. So our formula is going to be T buns equals 6 times by X plus 8 times by Y. And that's it. Right. Solve the inequality. So in an inequality, all you do is ignore the inequality, replace it with equals, and shove it back at the end. So we're going to rewrite this to be 6y plus 5 equals 8. Rearrange. So we've got 6y. Remember, I've picked up the plus 5, moved it to the other side, and it lands as a minus 5. So equals 8 minus 5. You're basically doing the opposite sign. Work that out. So we've got 6y equals 3. Then this is as times by 6, so I pick it up, move it on the other side, so it will land as a divide. So y equals 3 divided by 6, which obviously means y equals a half. Then you shove your inequality back in. So y is greater than a half. Done. Next one here, these little circles. Remember, this little circle means bigger than or smaller than. If it's filled in, you also have to include the equals. So what you do, here's an inequality, you bung the x in the middle, and then you say, right, x on this side has to be bigger, because the line's going in effect this way, is bigger than minus 3. But on this side, it's smaller, because it's going to the smaller side, or equal to 4. And that's it. Steve wants to put a hedge along one side of his garden. He needs to buy 27 plants for the hedge. Each plant costs £5.54. Steve has £150 to spend on plants for the hedge. Does he have enough money to buy all the plants he needs? So, there's 2 things here. One is working out how much he needs to spend on plants. So obviously if you've got 27 plants, each plant costs £5.54. That's going to be a multiplication. So we're going to do 27 times by £5.54. Ignore the decimal, and we're going to do 27 times 554. Grid method. So we're going to draw a 3 by 2 grid. We'll go this way. I've probably done this a bit small. So we've got 554. So we split it into the place values just how you would say the word or the number. 20 and 7. Then you're going to do 2 times 5 is 10 with 1, 2, 3 zeros. I have done it too small. 5 sevens are 35 with 2 zeros. 2 5s are 10 with 2 zeros. 2 4s are 8 with 1 0. 5 7s are 35 with a 0, and 4 7s are 28. Then we're going to add them up. You can obviously do 6 in a big row, but if we're getting into high numbers, that might lead to some errors. So if you can add it up in your head as you go, it makes it a little bit easier. So I know this is 13,500. Again, try and keep it nice and neat. Then we've got 1,350. Then this will make 108. And again, notice we're setting it out relatively neatly, just to show the examiner what we're doing. So we've got 8, 5, 9, 4, 1. So that's how much it's going to cost. However, remember, we need to count for the decimal. So there was 2 decimal places in the original sum, so the answer has to have 2. So we put the decimal there, and we can see that it's going to cost him 149.58. But remember, do not leave it like that. Look at the question. Does he have enough money? You have to write, yes, he does. Okay? As soon as you see this one, you know it's going to be an area question. And with these areas, we split them in half. However, there's a slight difference here. So again, if you get freaked out by the X's, don't worry about it. Just do what you would normally if it was a number, and you'll get some method marks. The area of the floor is 138 meters squared. Work out the value of X. So I'm going to split it into 2 nice areas and basically just carry on. So we have this area here is going to be this length times this length, which is 8x. This area here is going to be 8 and 3, so this side is 11. This side here is 15 minus x. So I'm going to multiply these two. So 11, 15 minus x is the area of this one. I'm going to expand that, which gives me 165 minus 11x. Then we're going to say 138 equals 165 minus 11x plus 8x. So I'm basically just adding these two together. Collect like terms, so we've got 138 equals 165, and then we've got minus 3x. Going off the bottom of the screen, I'll move that up. Then we're going to subtract this from this side. So this was a plus on this side, so it's going to become a minus. So we know it's going to be minus, and we look at the difference. So 2 makes 140, that's 22, 27. Minus 27 equals minus 3x. Divide, so we've got x is minus 27 over minus 3. The minuses cancel, so leave us with x equals 9. Oh, there, ha. You can go other routes. If you went this way here, that might end up with a nicer sum actually, but as long as you don't get confused by the minuses, you should be able to follow it through. Okay, this one here, don't know what you're doing yet, but you do know that you are going to not look at the x, you're going to look at the 65, what you do know. You're going to work it through, but we're also going to extend the lines, because that may or may not help us, but we're going to do that anyway. So I'm going to look, where are we going to start? Yeah, if I extend this line here as well. So we know that this is 65. Therefore, if you've got a line crossing parallel lines, this can be copied down here. So this is 65. Opposite angles are the same. So this is 65. Now if you see here, this and this mean this is an isosceles triangle, which means the base angles of an isosceles triangle are the same. So this also has to be 65. If you add them together and subtract from 180, adding them together gives you 130. And you subtract that from 180, means that is 50. Angles in a straight line here add to 180, which make that 130. You can annotate it on here. You can obviously do some of your working out here, which you should do. And because it says here, give reasons for your answer. So x is 130. My reasons would be, just as I've said, is talking through opposite angles here, parallel lines, base angles are the same, angles in a triangle add to 180. And you just write that out there, just how you, exactly how you'd explain it. Oh, x equals 130. Okay, with reasons. Questionnaire, easy marks. He wants to find out how far people live from their nearest supermarket. He uses this question on a questionnaire. How far do you live from your nearest supermarket? And you've got 0 to 2, 2 to 3, 3 to 4, 5 to 6. Write down 2 things wrong with this question. Well, usually you've got a time frame, but you don't need that for this one. However, he's left off, is that miles? Is it kilometers? Is it meters? Is it centimeters? There's no units. So that's one thing that was wrong. No units. Also, we've got overlapping boxes. If you were to live 2, let's assume it's miles, would you put it in that box or that box? Same for this and this. So we've got overlapping boxes. Another thing that's wrong with it, he's got no bigger than 6, so over 6 he hasn't got. So that's the third thing that's wrong, you only need 2. Jack also wants to find out how often people go shopping. Write a question Jack could use on his questionnaire to find out how often people go shopping. So, how, and you're basically going to repeat what they say in the question, but you're going to include a time frame and some boxes. So, how often do you go shopping? Add your time frame in per week. Question. So then usually they want at least 3 response boxes, so I'd probably do 4. So you go 0 to 2 times, because you don't need to say it's no units this time because you've included the time frame. Make sure it's not overlapping. So we've got 3 to 5, 6 to 8, and maybe say more than 8. They typically don't like for discrete data a greater than sign, so I'll just say more than 8. Like a user ruler and compass. I don't have compass, so I'm just going to sort of make marks and hopefully you'll get it. To construct perpendicular. So perpendicular means 90 degrees. From point C to the line AB. So we're going to have something which goes from here down here, but we're not allowed to use a protractor. We have to use compass and some a ruler. Probably don't need, oh, you only need the ruler to draw it in. So what you do is you get your compass and you basically put the point on there and then you extend it to beyond this line and you make some marks. So you're basically going to have mark there and probably a mark there. Then you get your compass down here again and you're going to basically make a mark down here. Same distance from here, make a mark down there and then join it with a ruler and that will be your perpendicular bisector. So again, you go from here, you make a mark, go down to these lines, make a mark, done. Ria is going to buy a caravan. The total cost of the caravan is 7,000 plus VAT at 20%. So already I'm thinking here I'm going to work out what 10% of it is and then scale it up. Ria pays a deposit of £3,000. She pays the rest of the total cost in 6 equal monthly payments. Work out the amount of each payment. So there's a lot of stuff here. Obviously it's worth 4 marks. So if you don't know the full thing, just go line by line and work out what you can. So the first thing to do is to work out 20% of 7,000. So I would say 10% of 7,000, and you basically divide by 10 is 700. So 20% is 1,400. So the total cost of the caravan, so again here you'll say total cost, and again you're writing it down, you're telling the examiner what you're going to do, is 7,000 plus, we've worked out the 20%, 1,400, which equals 8,400. So that's the total cost. She pays a deposit of £3,000, so we can take that off of the price. So we can minus £3,000, which gives us 5,400. Then she pays the rest in 6 equal monthly payments. All you need to do is divide it by 6. So don't be afraid of the division, don't think about it too much, don't get stressed about it, you just write out the method and follow it through. So 6's into 5 don't go, 6 is into 54. You can, if you have to, just work up your 6 times table until you get there, and you'll find that it's 9. 6 is into 0 don't go, or to go 0 times 6 is into 0, 0. So each monthly payment is £900. Question 12, factorize. So that is the opposite of expanding a bracket. So you look at it and you're looking for either a common number, common multiple factor, or common letter. Here we've got a common letter. So we're going to take one e outside the bracket, and we're basically going to, that's like you were dividing. So we're going to say this divided by the e just leaves us with 3e. And we can check we're right by re-expanding. E times 3e gives us 3e squared plus 5. That's it. Obviously write that over there, and don't leave it there. So we've got e bracket 3e plus 5. So on this one, solve. You may not know how to fully solve it, but if you see a bracket, expand it. Might give you a mark. So we've got 7k minus 21, which is 7 times k and 7 times 3, equals 3k minus 5. Now you're wanting to get all the k's on one side and the numbers on the other side, remembering do the opposite when you're moving something. So plus becomes minus, minus becomes plus, times and divide. So I'm going to move the minus 21 to this side, which gives me 7k equals 3k minus 5 plus 21. Then I can simplify this, so 7k equals 3k. Minus 5 plus 21 is the same as 21 minus 5, so that will be plus 16. Take the 3k to this side, so I'm going to be minusing 3k from this side, which leaves me with 4k equals 16. This is a times by 4, so I've got k equals 16 over 4, which is 4, so k equals 4. Expand and simplify. So our expand, we're going to do FOIL. So first, outside, inside, and last. And you can either write F-O, give that up, there you go, F-O-I-L, or personally I just go straight there. 2x times x is 2x squared. Outside is this one here, so that is minus 16x, remembering these are all timesing. Inside is plus 3x, and then our last will be minus 3/8 are 24. Then if we collect like terms, we're just left with 2x squared. We've got the minus 16 plus 3 is minus 13x, minus 24 sits on the end. So you get 1 mark for expanding, 1 mark for collecting. Last one down here. Put my arm around the other side of the camera there. Last one here, solve. So we're going to move the 4 first. So we should have 7 minus 3 f equals, it was a divide, so it comes up here as a times. So 2 4s are 8. Then I'm going to move the 7, so I've got minus 3f equals 8 minus the 7 becomes a 1, and then I can divide through by the minus 3, so f equals 1 divided by minus 3, because minus a third. Okay, express 180 as a product of its prime factors. These didn't used to come up on the higher, it was typically on the foundation, but they've been coming up more and more. So if you rack your memory, you start at the top with 180, and then you basically say what times what makes 180, and you can go in any route you like. If it's even, it's often easier to just divide by 2. So 2 90s. If it's prime, you circle it. Remember, a prime number cannot be split up. It can only be divided by itself and 1. So if you tried to, you'd end up with 1 and 2, and you wouldn't be able to go any further. So 2 times 45, circle it. And you've got 5 times by 9, circle 5, and then that you can split into 3 and 3. So those are your prime factors. Product means times, so we write this as 2 times 2 times 5 times 3 times 3. Or if you want it to be really clever, 2 squared times 3 squared times by 5. Okay, this is actually a reasonably hard question, I guess. Martin thinks of two numbers. He says the highest common factor, HCF, of my two numbers is 6. The lowest common multiple, LCM, of my two numbers is a multiple of 15. This is one where you're not going to know the final answer. You're just going to have to trust yourself and write down stuff that you know. So highest common factor of the two numbers is 6. So the highest common factor, reversing that means it's got to be bigger than 6. So if we write down for the HCF, it could be 6, could be 12, could be 18, could be 24. This has 6 as a factor for all of them. It's basically the multiples of 6. Could be 30, could be 36, etc. The lowest common multiple of my two numbers is 15. So you're looking for basically here numbers in this line which in their times table will have a multiple of 15. So your multiples of 15 are obviously 15, 30, 45, etc. So once you've played around with that, you can hopefully see that, and there's quite a few of these numbers which will satisfy it. That's 6 and 30. Both have factors of 6. Highest common factor is 6, and the lowest common multiple, if you multiply that up, you'll end up 6, 12, 18, 24, 30. But just writing down these two things will give you some marks. Okay, this is one of these questions. The maths is actually quite easy, but reading it is the hard bit. So take your time, think of it line by line, and just work it out as you go. So Suha has a full 600 milliliter bottle of wallpaper remover. She's going to mix some of the wallpaper remover with water. Here is the information on the label of the bottle. 600 mils of that. Mix a quarter of the wallpaper remover with 4,500 mils of water. So once I've seen that, I'm thinking a quarter of that obviously is going to be half it and half it again at 150. So I'm going to make a little note here saying a quarter of 600 is 150. Suha is going to use 750 mils of water. How many millilitres of wallpaper remover should she use? So you're basically saying how many times does 750 go into that? So you can basically write down your 750 times table, because we all know that 3,750 and then 4,500. So that is basically 1, 2, 3, 4, 5, 6. It's 6 it's a sixth of that. So going from this, we basically just need to divide this by 6. So how many 6s go into 150? 6s into 1 don't go. 6s into 15 go twice, remainder 3. And 6s into 30 go 5. So just to recap quickly, we've done quarter of the wallpaper is wallpaper remover is 600 divided by 4, which is 150, and then she's used a smaller amount than she needs by 6 times smaller. So again, we've divided by 6 to give you 25. Remember to write the answer down. This is one of these which looks horrible, but it's actually quite easy. It's related to cumulative frequency. It's a box and whisker plot. They've even given you down here a nice version of what it should look like. So, and up here, they've given you basically what you need to plot. In a slight different way, they often give you the lowest, the highest, the upper quartile, lower quartile, and the median. But here, they've thrown a bit of a curveball, if you like, and giving you the range. So the least amount of time is 60. So we should be able to draw, I'm not going to bother with the ruler. Here, actually, yeah, be careful of that. If you look at your scale, 60 is actually there. Then we've got the highest one. Now the range is obviously the biggest minus the smallest, so we need to basically add these two together to give us 290. So we've got that here. Then we can plot the others. Median is 170, lower quartile is 100, and the upper quartile is 220, which is here. Again, do be careful of your scale. Then you just make it look like the one down the bottom. Okay, 2 marks. Then it says the box plot below shows information about the amount of time the boys spent doing homework last week. This top one, the one you plotted, is the amount of time the girls spent doing homework. It says compare the amount of time the girls spent doing homework with the amount of time the boys spent doing homework. So you may basically need to make a couple of statements about this. The two things they're looking for you to make a statement about is comparing the median. So you could say the boys' median time spent, median is average obviously, is higher than the girls. Then they're also looking for some kind of comparison of the range. Now, so I'm just going to write a note here. So you got median. Obviously do that in a sentence. So you'd say the boys spent on average, bracket median, longer. They're looking for a comparison of either the interquartile range, which is this value minus this value, or of the full range, which is this value minus this value. So basically pick one of them, whether it's the interquartile range or the actual range, which might be the easiest one because they've given you it up here. 230, this one is 210. And so you'd say the range of the girls is bigger than the boys. So those are the two comparisons you need to do, or the interquartile range. Again, in proper sentences, you'll notice the star here. We mentioned that at the beginning. So your quality of your written answer will be taken into account, not just the maths. So here's cumulative frequency. As soon as you see the word cumulative, you know you're going to add them up. And then we're going to plot the endpoints against the added up cumulative frequency. However, be careful. With this one, they have already given you the cumulative frequency, so we don't actually need to add it up. If they'd have given you the frequency, that means you'd then have to add it up. So be careful. This is the first time I've seen it like this. Most of the time they will get you to add it. So yeah, be a little bit careful with that. So I'm gonna move this and then quickly plot the graph, but I'm basically plotting this endpoint against my cumulative frequency, which is already worked out. So very quickly, we've got 20, 25. We've got 30 and 70. Again, look at your axes. You've got cumulative frequency there and age down here. 40 is 138. 50 is 175, and it should end up with this sort of pushed over S shape. 60 is 186. Again, looking at your axes, each one of these is worth 2. 70 is 194, and 80 is your 200. So you can go from the 0 down here and basically do a sort of freehand, but relatively careful, a lovely curve. So that's our cumulative frequency. 2 marks. Graham says 10% of the workers at the factory are older than 65. So again, it's worth 2 marks. So what you can do is 10% of, you can look up here and go, right, 200 workers. So 10% is 20. So we can reread that. 20 of the workers of the workers of the factory are older than 65. So what you do with that is, just like with your scatter graphs or working out the median, you find what they're on about, i.e. they're on about this, 65. We draw a line up, obviously with your ruler a bit neater than I'm doing, hit your line, go across, take a reading. So it said, we've got that's 192. So it said 10% of the workers, which we've worked out as 20, are older than 65. Well, it's not, because we've got 200 workers and 192 are at 65, which means the ones that are older, there's 8 that are older. So incorrect. And as long as you've got your working here and up here for the percentage, then you're all good. Okay, this one, there's a couple of ways you can approach it, but the points to note: regular, octagon. Okay, so it means all the sides and all the angles are the same, which hopefully you'll realise that you can work out, if you look at the question very quickly, work out the size of angle KFE. So we're after this angle here, so we'll call that X. Now this bigger angle here we can work out, because that's an octagon. So if we had an 8-sided shape, I'll quickly sketch one out. 1, 2, 3, 4, 5, 6, 7, 8. I'll use a different colour pen. If we break it into triangles, we can see there are 1, 2, 3, 4, 5, 6 triangles within an octagon. So we know there's 180 degrees in a triangle, so if you multiply that 6, that will give me how many degrees there are in the octagon. So we've got, you can obviously do this grid, or you've got 6 times 100 is 600 plus 6 eighths, 480 with the 0, which gives us 1080. Now there's 8 angles, so we can divide that by 8. So how many 8s go into 1080? So we've got 8s into 1 don't go, 8s into 10 go once, remainder of 2. 8s into that go 3 8s are 24, so it's 3 with a remainder of 4, and 8s into that 5. So I now know that this bigger angle up here is 135. Now if we take our ruler and we split this here in half, we've now made a 4-sided shape. So we've got, this is 70 and this is 70. So adding them together gives us 140. But again, we know, because of it, it's symmetrical and regular, that if that's 140, we've got 360 degrees in a 4-sided shape, for the same reason as that, if you want to work that through and prove it yourself. So 360 minus 140 gives us, because of the 270s, gives us, what's that, 220, and we split that in 2, which gives us 110. So we know that this is 110. The whole thing is 135. So 135 minus 110 leaves us with an answer of 25 degrees. Kind of a tricky question, but if you start looking at it and thinking, well, what do I know about an octagon? Let me draw a line there and look at these shapes and things, but noticing that it's a regular octagon and it's all symmetric is your key for that. Question 18, we've got some trapeziums. So you could, if you had a height, maybe go back to the formula sheet and look at this for the area, but typically that would come earlier in the paper because that would be quite an easy question. So this one's all about scale factor. And the key thing about scale factor is you just multiply it to get a length, but with an area you have to actually square the scale factor, and with a volume you have to cube the scale factor. So we'll deal with that as we go. Work out the length of AB. So we're after this length here. Now if that's 5, we've basically times that by the scale factor to get the full length. And how we get the scale factor is here. We've got, this is 12 and this is 18, so you're basically looking for the scale factor here. So our scale factor, what do you multiply by 12 to get to 18? Well, double that is 24, so basically it's time and a half. So the scale factor is 1.5. So all we do is take 5 and we times it by the 1.5, which gives us 7.5. Okay, this one's a little trickier. Trapezium AEFG, so we've got move this up and down. AEFG has an area of 36, so this is 36. Work out the area of the shaded region. So what we're going to have to do is work out the area of the full thing, and we're going to subtract this area. Now remember I told you that if the scale factor was, just a length, we had to square it. So the scale factor for the area is 1.5 squared. Now if you square 1.5, again, you can grid method it if you want, but it's basically 15 times 15. In fact, yeah, we'll do that. So 15 times 15, you do it like this. So that's 100, 50, 50, 25. Add that together gives you 225. Remembering to put the decimal back in, so it's 2.25. So what we can do is, oh sorry, I didn't realise I was out of shot, there you go. Now, so that's our scale factor, so we're going to take the area and we're going to multiply it by the scale factor. So we're going to do, again this is good practice if you're struggling with your multiplying, 225 times by 36, which should give me, again, a grid method, because it is safe and it works. 36, 225. Remembering we're going to put the decimal back in. So 2 3s are 6 with 1, 2, 3 zeros, 2 3s again are 6 with 2 zeros, 3 5s are 15 with a 0, 2 6s are 12 with 2 zeros, 2 6s are 12 with a 0, and 5 6s are 30. So adding that together gives us 7,200 plus 720 plus 180, which gives me 0, 0, carry the 1, 7, 8, 9, 10, 11, carry the 1 is 8. 810, 81. So our area of the biggest one is 81, and then we subtract the area of the smaller one. So just for completeness, I would do that and show them my working. So it should be 45 centimetres squared. Graphs from equations, they've been nice here, they've given you the table, so we're basically going to shove our value of x into the equation here and see what we get out. I'm going to start with the bigger numbers, or you're staying away from the negatives really, or the halves, because then you'll be able to hopefully spot a pattern. So 4 divided by 8 is 0.5. 4 fifths I know is 0.8. 4 over 4 is 1. So we can kind of see from here we are doubling, doubling, doubling. So 4 divided by a half is 8. Then you just plot them. So 8, 0.5, remembering it's along the corridor and up the stairs, along to 5 up to 0.8, along to 4 up to 1, 2 and 2, 1 and 4, 0.5 and 8. So again, you've got a nice curve there. Done. So we're on to question 20. The diagram shows a solid shape. Here it is. The solid shape is made from cylinder and hemisphere, so that's half a sphere. The radius of the cylinder is equal to the radius of the hemisphere, so all that's saying is here, if you've got a radius there, it's the same as here. The cylinder has a height of 10 centimeters. The curved surface of the hemisphere is 32 pi centimeters squared. So we already know that is 32 pi. Work out the total surface area of the solid shape. So what it's asking for is this surface area here plus the surface area here. Now if you think of a can of beans, if you took the wrapper off, it'd actually look like a rectangle. Now we know this is 10. This distance here came from wrapping around our can of beans. So that is basically the circumference which we should hopefully know circumference is 2 times pi times by the radius, which we don't know yet. Then you've obviously got the bottom here as well, and this is an area, so the area of a circle is pi times by the radius squared. So we need to work out what the radius is. Now they've given us this, and hopefully you can remember from your formula sheet, put that back on there. Down here we've got the surface area of a sphere is 4 pi r squared. Now we've got half a sphere, a hemisphere. So we've basically got down here 32 pi equals 4 pi r squared, but we need to half it. So if we rearrange that, we've got 32 pi is 2 pi r squared. The pi will cancel, divide through by 2, and we've got r squared equals 16. So r equals the square root of 16, which equals 4. So now we can take that and put that back up into here. So the full thing will be 32 pi, which is the area, the surface area of the hemisphere, plus the area here, which we get from 10 times by 2 times by the radius, which is 4, times by pi. So that equals 2 4s are 8 times 10, 80 pi, plus the area, which is pi times by the radius squared, so times by 4 squared, so that'll be 16 pi. Add that all together, excuse me, 8, so 8, 9, 10, 11, 12, so it should be 128 pi is our answer. Which obviously would then write down here. On the calculator paper they may ask you to work that out and round it to decimal places or significant figures, but here it said it's fine, give your answer in terms of pi. Question 21 is a third question, which is the square roots, but it should be relatively simple if you know how to deal with surds, because it's just a two bracket expansion, so a FOIL expansion. So I'm going to do first, 1 times 3 is 3, plus, actually not plus, the outside, which will be minus root 2. That's our outside, our inside, plus 3 root 2, and our last, which will be minus 2. Collecting that all together, and we've got 1. We've got minus a blob, plus 3 of the blob, so that's plus 2 of the blob, which is root 2. And you can see it'll end up in this form. Done. Anything to the power of 0 is 1. So it doesn't matter what the thing is, the answer is 1. This one here we can treat in several stages. A minus, which means 1 over. And then we've got a half, which means square root. So I'm going to do, it was worth 2 marks, so we're going to do it in stages. With the minus, you basically do 1 over or just flip it upside down. So that equals 25 y squared over 64 x to the 6. And all of that we still need to square root. And then we can do that. The square root of 25 is 5. Square root of y squared is just y, over square root of 64 is 8, and the square root of x to the 6 is x cubed. And we're done. This next one, if you're uncertain of what to do, go back to how you would subtract, say, you know, a third minus 1/8. That's where you're going to multiply the bottom two together, and then you're going to cross multiply those two, and then work through the algebra. So we would have 5 bracket x plus 3, so that's that times that, minus 4 bracket x minus 3, so that's that times that, and then on the bottom we would have them times together. Once you've got that, you just then work through the algebra. So we've got 5x plus 15 minus 4x plus 12 all over x squared minus 3x plus 3x minus 9. Collect your like terms, so we've got x plus 27 over x squared minus 9. Done. Last two questions, so big boy marks now. Paul has 8 cards, there's a number on each card. Paul takes at random 3 of the cards. He adds together the 3 numbers on the cards to get a total of T. Work out the probability that T is an odd number. So this typically will be one where you're going to draw some kind of probability tree. If you try and do it though for all of these cards, you're going to end up with a massive tree, more like a forest, which we don't want. So you can do that, you can simplify this by looking at the actual result. He's got to take 3 cards and add them together. So if we look at odds and evens, if we take even numbers, even, and add them together, so we'll use 2. 2 plus 2 plus 2 equals 6. So that will always get you an even number. So we don't want that. We want the probability that's an odd number. So we're interested in odd plus even, or, which will get you an odd number, even plus odd plus even, or even plus odd, or, well, if we've got, a couple of odds, that makes an even, so that's not going to work in any combination. Or the other one could be 3 odds in any combination. So we're after the probability of getting those. So then if you draw your probability tree, we've got on the first one, odd, even, and then we've got odd, even, odd, even, odd, even, odd, even, odd, even, odd, even, and then you can basically work it through. The other way you could do it is do 1 minus the probability of it being an even number, and that we get it. The only thing to remember, I'm not going to go through the full thing, but the only thing to remember is when you're moving along this probability here, you are timesing the fraction. So just as a quick reminder, 2 over 3 times by 4 over 5, what you do is times the top and times the bottom. And then once you've got these individual probabilities, you add them up going down. So say if you've got 2 over 100, for argument's sake, plus 4 over 100, that would give you 6 over 100. So as long as you've got that first bit down, then you should be absolutely fine to finish that off. A is the point with coordinates 1, 3, B is the point with coordinates 4, minus 1. The straight line goes through both A and B. Is the line with equation 2y equals 3x minus 4 perpendicular to the line L? So the important points with this, if you rearrange this first equation into the format y equals mx plus c, this is your intercept with the y-axis, and this is the important point in this question, this is the gradient. Now for a perpendicular line, the gradient is minus 1 over m, so that's what we're after. So if we rearrange this, y equals 3 over 2x minus 2, we've divided through by the y. So with the gradient we're looking for is minus 1 over that, which will give us minus 2/3. And then you're going to basically compare these up here. You can plot them if you like on a little graph, and you can work out for going along one how far you'd go up, and this is the answer you're basically looking for, which will tell you whether it's yes or no. Last question, we're on to graph transformations. Don't worry too much about the f bracket x. All you need to know is how graphs respond and move when you do things to them. So we have this minimum point here, which is 3 along and minus 4 down. So we've basically got this. Adding or subtracting moves the graph up or down. So if we were to move this up 3, we would end up at the 3 coordinate stays the same, but we go up 3. So it'd be 3 minus 1. This one here, it could be on the outside, which does different things. The inside basically will squash it by a scale factor. So again, we're going to basically squash it the x direction, so it's going to end up over here, which would be 1.5 and minus 4. Lastly, the minus over here, if it was outside it would be a flip in the x-axis, but the minus on the inside flips it in the y direction, so we'd end up with minus 3. Minus 4 wouldn't change. So that's it, we're done. 100-ish%, jobs are good.